Will Tesla bots help us live on Mars? Is life possible on a tidally locked Earth 2.0? And where did life start anyway? All these questions and more in this question show. Happy 2025. It's time for the question show. Your questions, my answers. As always, wherever you are, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Ali H. Said. What do you think would happen if we figured out how life first formed? How would it affect the search for life elsewhere in the universe? So obviously right now in the end of 2024, early 2025, the only concrete evidence that we have of life in the universe is here on planet Earth. Now, on planet Earth, life has found its way into every single nook and cranny. Wherever life can exist, it does exist, with a few interesting exceptions. There's some places where life could exist, but it doesn't exist, like on fresh lava flows, things like that, which is a story that we're working on Universe Today. It's really interesting. But anyway, so we don't know of any life anywhere else. We don't know of any life on Mars. We don't know of life on Europa and Enceladus. We have not detected any biosignatures in exoplanets with our big telescopes. But the hunt is on. Astronomers are looking through their telescopes at other planets. SETI researchers are listening for signals coming from other advanced civilizations. There are missions on Mars right now that are looking for past evidence of life. There's a mission going to Europa, multiple missions going to the Jupiter system that's going to be looking for life. But there's also a big question, obviously, about how life formed here on Earth. And the two processes, this idea of abiogenesis, right? How do you go from non-life to life? This question might get answered either here on planet Earth, or it might get answered by finding some evidence of life on another place. Because now you have this comparison. You could say, well, what were the raw ingredients that were available on Earth? What were the raw ingredients that were available on Mars? How could life have gotten going in one or the other of these circumstances? And so if we did figure out how life formed on Earth, how you got that process of abiogenesis, then that would give us an understanding of the kinds of places that we should be looking. It allows us to narrow our search, but it also kind of doesn't. Because even if we did find, we did figure out and scientists were able to reproduce abiogenesis in the lab. They're able to take a jumble of carbon molecules and water and hit it with electricity and then expose it to volcanic gases and then, right? And they were able to get some kind of first rudimentary life forming. Then the kinds of conditions that we have here on Earth, we kind of knew what conditions were available on Earth, whether it was, was it that it first formed down in the deep sea vents? That would be really interesting because that would tell us, okay, let's maybe search for places with deep sea vents like Europa or Enceladus. Did it form on the surface under a certain kind of atmosphere? Okay, maybe a place like Titan is a better place to be able to search. And then as we look out into the universe, we think about other worlds and go, okay, these are the worlds that have the kinds of atmospheres that match the kinds of conditions that life was able to form on Earth. So it works both ways, that if we figure out how life first formed on Earth, then that tells us where to look out in the universe for other examples of life. If we find life in other places, then, in addition to Earth, then that gives us hints and clues about how life might have formed on Earth billions of years ago. So either way you go about it, it will be a revolutionary discovery if someone ever finds it. Nathaniel Benjamin, what are you most excited for in 2025? 3 guesses and the first 2 don't count. I am most excited for the Vera Rubin Observatory. And this is a telescope that is down in Chile. And it is going to be scanning the entire night sky every couple of nights from the southern hemisphere. And then the telescope will be storing about 20 terabytes a day of data about the universe. And because it's coming back every few nights, anything new that has happened, any asteroid that has moved, any comet that's moved, any planet 9 that has moved through the field of view, any new supernovae, any other weird things that the universe is doing when we weren't looking will have been recorded. And you'll be able to sort of do this comparison, say, here's what the night sky looked like 3 nights ago. Here's what the night sky looked like tonight. What's everything that changed in that time period? And astronomers have been looking in the sky for hundreds of years. And you think about these big catalogs, the Messier catalog. There are a lot fancier catalogs that have come out more recently with tens of thousands, even millions of objects. You think about the Sloan Digital Sky Survey and these other large surveys of the sky. And they are looking at the universe in the perspective of just space. Here's where all of the things are, but very little work is being done from the perspective of time. Here's how the universe is evolving and changing over time. There's a few things that do this. There's observatories that are looking for transient flashes, telescopes that have been looking for gamma ray bursts or fast radio bursts or various things that are kind of known that can happen in the sky. But with Vera Rubin, it is just this drift net that is just going to watch this huge chunk of the entire sky and try to highlight to astronomers anything that changed from night to night to night to night. And that's really exciting because it's going to be looking at the universe in an entirely new way, adding an entirely new dimension, time, in a way that we've never had before. And so I'm anticipating being really busy in 2025 because we're going to get the discovery of potentially hundreds of thousands of new asteroids. We're probably going to find Planet 9. We're going to find tons of new comets. We're going to find, like right now, astronomers know of like 3,000 Type 1a supernova. Vera Rubin's going to find 1 million of them. So it's just like anything that changes on a regular basis, Vera Rubin's going to find it. And then it's going to find a whole bunch of things that nobody asked for, nobody planned, nobody was expecting to see. Only those things that you can see when you're watching everything all the time. And I'm here for it. So that is absolutely the thing that I'm most excited for in 2025. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed and welcome to our recent newcomers. Brad Gibson, Bear Lake Roofing, Flo, Paul Esposito, Robert Riddell, and Martin Van Dorp. Join the club at patreon.com/universetoday. Rev Keith Carter. If an exoplanet is tidally locked, it can't qualify as Earth 2.0, can it? It sort of depends on the situation. So, here on Earth, we are located 1 astronomical unit away, 150-ish million kilometers away from the sun. Our sun is a yellow dwarf star. The Earth has been around for 4.5 billion years. And that there are other planets in the solar system. And the Earth has a large moon that is sort of helps with its stability and potentially the formation of life on our planet. The Earth has a magnetosphere that protects it from radiation, both solar radiation as well as cosmic radiation. So what does Earth 2.0 mean? And obviously Earth 2.0 sort of tells you like it's the better version. Like you've got Earth 1.0, that's the first release, but then Earth 2 comes out and it's better, stronger, faster. And of course it's not. I mean, the hope is that the second Earth, another Earth, will be an example of a planet that fits the same criteria as our planet, right down to the presence of life on that planet. And once you start to mess with some of the variables, you're now starting to wander away from what is a true copy of the Earth. So, right now, astronomers don't know of any Earth-sized worlds orbiting around a sun-like star within the habitable zone of that star, a place where liquid water could be present. Astronomers know of Earth-sized worlds orbiting around red dwarf stars within the habitable zone. They also know of Earth-sized worlds orbiting around sun-like stars, but not in the habitable zone. So they know of all of these combinations, but you don't get the 3 lining up perfectly. Sun-like star, Earth-sized world, habitable zone. We're still waiting for that. And that, we will shorthand call that Earth 2.0. But then there are other things. Like if you get a Earth-sized world orbiting around a red dwarf star, it is, as you said in your question, almost certainly tidally locked in the same way that the moon is tidally locked to the Earth. And the moon always shows the same side to the Earth, that Europa and Io, Ganymede, they're all tidally locked to Jupiter. And you're going to get this situation across the entire universe. As long as your planets are close to the star, they're going to be tidally locked. But being tidally locked, like the question is it another Earth? Well, no, it's not a sun-like star, it is a red dwarf star. So now this is not Earth 2.0 because you've got this Earth-sized world in a habitable zone around a star that is nothing like the sun. And the implications of that is you're going to get this planet being tidally locked to its star. But, like the question I think you're asking is, does that disqualify it as a place to look for life? And not at all. I think for the longest time, astronomers thought, well, if you get this planet that's tidally locked to its star, then one face is going to be facing the star and it's going to be burning hot. And then the other side is going to be facing away from the star. It's going to be freezing cold. And the only place that you might be able to get some reasonable conditions is going to be on the terminator around the planet. That sort of the in between the daytime and the nighttime, you're going to have a few hundred kilometers where temperatures are reasonable, light is falling, it's not baking, but it's also not cold. And more recent exoplanet simulations show that, in fact, it's probably a lot more reasonable than that. That what we see are on tidally locked planets, you get these tremendous winds that are pulling hot atmosphere away from the side that's facing the star and driving it to the side that is facing away from the star. And that helps to regulate the temperature on this planet. And so instead of it being like it's just like a baking oven on the near side and then a freezing cold freezer on the far side, it actually would be more like a kind of steamy jungle, like I guess what people thought Venus was like before we realized that in fact it is hell. But so you could have, say, temperatures that are habitable. You have liquid water on the surface. You're going to have a lot of water vapor in the atmosphere. You could have a lot of plant life that is being supported in that, and animal life. And then you're going to have these winds that are going to be distributing that cool air around to the back of the planet. And then cool air is going to make its way back over through ocean currents and other sort of wind currents to help cool down parts of the planet. And so in the case of a planet that is tidally locked to its star, then you're probably going to get one hemisphere that is habitable. And then the part that's dark, it's probably, there's not a lot of sunlight that falls on the dark side. But you can also imagine situations where you have, say, a planet like a big gas giant like Jupiter that is orbiting around a red dwarf star or orbiting around some other kind of star. And the sort of the gas giant is tidally locked to the star. But it could have a moon, and the moon is tidally locked to the planet, but then the moon is also orbiting around this planet. And so from the perspective of being on the planet, you are seeing a whole day-night cycle as you go around your gas giant. So there's a lot of scenarios that people have thought through, and our ideas of what is habitable and what is not habitable has really widened. This whole idea of these Haitian worlds, where you've got this planet with a sort of thick layer of water and then a thick hydrogen atmosphere, that could actually extend way out from the traditional habitable zone, that this thick hydrogen could act like a blanket that keeps the water liquid well beyond, like maybe all the way out to, say, Jupiter. And so now your idea of like how big is the habitable zone really depends on the composition of the atmosphere. So now that we've found a lot of exoplanets, now that we're really starting to make these kinds of observations, now that we're starting to realize these are the kinds of different variations that are out there in the universe, astronomers are starting to sort of be a lot more open-minded about the kinds of places that we should be looking for. And obviously, when you think about how we've got large amounts of liquid water underneath the ice here in the solar system at Europa and Enceladus, Pluto, Mimas, all these places, that also expands the places where we could potentially look for life in the universe. And so I think, are we going to find a carbon copy of Earth out there? Absolutely. It's just a matter of time before we find it. But is that the only place that we should be looking? Absolutely not. We should be looking at all the places. Dougal, do you think elements on the island of stability exist somewhere out there? People always ask this question that, is it possible that there are elements with many more protons than the ones that we find here on Earth, or even the ones that we've been able to create in the lab? And I don't know what the highest number in the periodic table of elements is, but that's something that can only exist for a few attoseconds before it decays. It requires enormous atom smashers to be able to, create these larger and larger atoms. And so, the amount of energy that humanity is able to bring to bear in a small space with something like the Large Hadron Collider is still orders of magnitude, I think like 6-7 orders of magnitude less than what the universe is capable of doing with supernovae and things like that. And so we're still a long, long way from being able to create anything that holds a candle to what supernova and neutron stars, colliding neutron stars, can do. And yet we here on Earth, we're left with a certain number of elements. We're left with iron and gold and carbon and all of these different elements leading up to a certain point. And then beyond a certain point, we don't see any of those heavier elements. They've all decayed, radioactive decay. And so the most powerful atom smashers in the universe have not created anything that is beyond what we find here on planet Earth that we can tell. And so you can sort of safely assume that there are no more stable atoms further up the periodic table beyond what we've already discovered. Now, in the zillionths, which I believe is a technical number, of a second after these giant neutron stars have collided with each other, you're going to have unimaginable forces where you are just a fraction away from the amount of force required to turn matter into a black hole. You can imagine there are some monster atoms being formed, but they are decaying almost instantly into other things. And in many cases, it's that decay of elements that is actually driving a lot of the energy coming out from these collisions. So, the universe is capable of creating elements wildly beyond anything we can do here on Earth, and yet we know that they must decay almost immediately. Squeal, what do you think about the idea of SpaceX sending starships full of Tesla bots to Mars to prepare for human arrival? Are those bots even able to survive on Mars? That's really interesting. So, would that work? Sure. We've sent robots to Mars, and so if you sent a whole bunch of Tesla bots to Mars, could they survive? They probably could survive, although they're not built for the kind of environment that Mars can throw at them. When you think about a rover like Curiosity or Perseverance, it's custom built to be able to handle, both its shape, it's squat, it has 6 wheels, rolls around, as well as all of the internal workings of this rover were designed to be hardened to be out there exposed on the surface of Mars for long periods of time. It's made of metal. All of the computers on board are hardened, radiation hardened for space, are made out of relatively simple computer components that we know work for long periods of time in the rigors of space. And so think about a Tesla robot. I mean, is it made of plastic? How well will plastic work out there on the surface of Mars for long periods of time under the intense, radiation from the sun? It'll crack. You'll probably need to change what these things are made out of. Think about the computers that are running on them. I mean, they're running on incredibly advanced, very, small nanometer chipsets, because they require a ton of processing, while a Tesla bot, it probably has, many orders of magnitude more computing power than Perseverance or Curiosity. And so they would be very fragile, and the odd cosmic ray would cause all kinds of problems to their functioning. And then they require a certain amount of infrastructure that, these robots are going to need a place to charge themselves. Okay, well, you're going to have to bring the charging situation. Well, the charger is going to require solar panels or a nuclear reactor. Okay, you're going to need to send the nuclear reactor and the solar panel array that's going to be able to keep all of these bots going. And then what are they going to be doing? I mean, are they going to be digging regolith with their hands? No, you probably want an excavator. Okay, you're going to be sending a giant robotic excavator that's going to go to Mars. It's going to be digging. Are they going to be driving the excavator? So, I think that we're at this point where like a humanoid robot will be really useful here in our house doing my dishes, unloading my dishwasher, doing my laundry, working in construction sites, in places that were built for human beings, that you need to be able to have a robot shape that can navigate around a human infrastructure. But once you're out on the wild openness of Mars, then the body plan of the Tesla bot just doesn't make as much sense. That, you're going to want something that is just only a bulldozer. It's a Mars bulldozer, and its job is to push around regolith. Another robot is a rock grinder that's only job is to take chunks of regolith and turn it into a fine powder. And, it doesn't look like a humanoid robot at all. So I think the humanoid type robots will only show up on Mars after we have the environments that human beings are already going to be living in, and you need robots that can work within those environments. All right, those were the questions that we had this week. There weren't a lot of questions, but they were pretty in-depth. So thank you, everybody who joined me for the live show when we actually recorded all of these questions. We do this every Monday at different times, depending on which part of planet Earth we are trying to represent. Now, I'm going to talk about predictions for 2025. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew Gross, Barry Lake Roofing, David Gilton, and David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, Sean Sargent, Spiderswap.io, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Now, I try to be a journalist and not a pundit, but for fun, let's do some predictions for 2025. And so I want to see in the comments below some questions that you have about the likelihood of various things happening. Stars exploding, rockets launching, missions happening, getting canceled. Let me know, and then I may try to put together a team of YouTubers and various space friends to try and sort of provide their ideas for fun on the likelihood of various things happening. So let me know in the comments down below some of the stuff that you want to see predicted. All right, we'll see you next time.